So good morning everyone and welcome to this lecture. In this lecture, we are going to deal not with vibration of air column, but we are going to deal with beats and Doppler effect. And this is lecture number 12. We're going to deal with beats and Doppler effect. So let's not waste any time and move ahead with the topic. Beats. What do you mean by beats? You would have heard this term in sound, music, beats. Beats बहुत अच्छी है. Beats are good. What do you mean by beats? Huh? What do you mean by beats? Huh?
No idea, sir.
You have not heard the term beat?
Sir,
You have not heard the term beat? Have you heard the term beat? Music
heard,
beats.
but we don't know about that.
They never use that term beat. Okay. It's all about music, beats. So, what is beat and when do you hear a beat? It's not heartbeat. It's music beat, sound beat. So, when two sound waves, and here the most important term is slightly different frequencies, and there must be sound waves. When two sound waves of slightly different frequencies traveling in the same medium along the same direction, frequencies are slightly different. They superimpose each other. The intensity of resultant sound, and remember, at a particular position. So if I'm standing here, the resultant of the intensity of resultant sound rises and falls regularly with time. So if I stand at any one point, I will hear sound getting maximum and sound getting minimum after some time. This phenomena of variation in sound with time at a particular position is called beats. This is what we usually refer to beats. Now, whenever we try to differentiate between interference and beats, we can write interference is superposition in space. Interference is superposition in space. So what I was saying was, whenever we hear the term interference, interference is superposition of two waves of same frequency, same direction, and it is superposition in space. At different points, you will get maximas and minimas, not at the same point. So we call it superposition in space. Whereas whenever we talk about beats, at the same point, you might get maxima, and after some time, you will get minima. So beats, we call it superposition in time. Do we understand the difference? You can call beats as superposition in time, whereas interference is superposition in space. I'll give you 2 minutes to note this down. Everyone understood the meaning of the term? At the same position, you will have varying intensity. Sometimes you may get maxima, sometimes you may get minima. This phenomena is known as beats. I'll give you 2 minutes to note this down. Well, there are certain terms that you must remember about beats, and I will give you those terms. First, understand them, and then I will give you time to note them down. Don't worry. The first term that you have to understand is how much, we'll get across these things. One beat. How much is one beat? Now, one beat, you are standing at one place and beats are happening, and there is interference or there is superposition in time. So you are going to hear maximum intensity, minimum intensity, maximum intensity, minimum intensity, and so on. Between one maximum to the other maximum, we say that there is one beat. One beat is said to be formed when intensity becomes maximum again after becoming minimum once in between. So between two maximum, we have one beat to be formed. Do we understand this? Yes or no? No or yes?
Understood, sir.
That is what I call one beat. One beat is said to be formed when you hear the maxima again, and in between you will get a minima. I hope you understand this. Let me just go through those terms. Okay, I can just show you this diagram probably. And remember, you don't have to draw this diagram. This is just for you to understand what I am saying, what is a beat. So again, try to understand this diagram. Now, this is the diagram. Now I'll give you the equation as well. Now you can see this is Y1, the first sound. This is Y2, the second sound. The frequencies are a bit different. Do you see this? Frequencies are a bit different. They don't
Yes,
have the same frequency. Yes or no?
yes, sir.
When they superpose, this is what you get finally. This one is what you get finally. And this is a beat. Got my point? The distance between one maxima to the next maxima, we call one beat. Do we understand this? Yes or no? No or yes?
Understood, sir.
Okay. This is just for you to understand. There is nothing that you can write over here. There is no point of writing anything. It's for just to make you understand. The second term that we are going to hear in beats is beat period. What is beat period? And it is very simple to understand. What would be beat period? In waves we have time period. In a beat we have beat period. So what is beat period?
The time period taken to
The
one beat.
time period between two maximas is known as your beat period. The inverse of that time will be known as beat frequency. Number of beats. Number of beats per second. Now, to hear beats, you must understand. You don't have to write the next point. This is just for your understanding. Human beings cannot hear, or your mind cannot distinguish two sounds if the time difference between them is 1/10 of a second. So if you hear one sound and after that if you hear one more sound in less than 1/10 seconds, your brain will not be able to identify and the sounds will mix up. So for beats to be formed, so that you are able to understand that there are two sounds coming and the intensities are different, your beat frequency must be less than 10. You just remember that your beat frequency, for beat to be heard and understood by your brain, the beat frequency, The difference in frequency should be less than 10, just for your information. Do we understand this?
Yes, sir.
Yes or no? No or yes?
Yes, sir.
Pakka, sir?
Yes, sir.
Okay. Now, if we talk, I hope you are writing it. Have you written it up till here? I will just give you one more and then I will give you time to write so that everything is there. Then the other thing which may not come, but it is good for your understanding if you remember this equation of beat. Now to understand how do you get equation of beat, what we have done here is we have taken two sound waves. Y1 is A sine omega t, amplitude is kept same, but frequency is different. Frequency, let me call it as F1 rather than N1. And we have taken the second sound wave as A sine omega 2t, 2 times F2t. Now, when they superimpose, the resultant wave will be given by Y1 plus Y2. Do we understand this?
Yes, sir.
The resultant wave will look like this. This is just sine A plus sine B ka formula we have used. We understand this?
Yes, sir.
Now this A is the amplitude and this tells us what is happening with the beats. And remember this formula for A. This amplitude is 2A cos N1, cos F1 minus F2t. Do we understand this?
Yes, sir.
This is the beat frequency. So I will just give you those two terms as well. And then I will give you time to write. Brief beat frequency is F1 minus F2 or F2 minus F1 depending on which is more. Do we understand this? And the
Yes, sir.
time period will be inverse of that beat frequency. So this is all about beats that you need to know. F1 minus F2 and 1 by F1 minus F2. Anyone understand what is the concept of beats?
Yes, sir.
Yes or no, no or yes. Now I'll give you 2 minutes. Note it down aram se. Let me know once you are done. Well then, let's move forward. And whenever we are going to do question on beats, there will be two tuning forks and you will have to find out the beat. You will have to find out the frequency of unknown tuning fork. Now, they will be sounding the two tuning forks together and then they will be doing something. The first thing they might do is they might add wax to a tuning fork. When you add wax to a tuning fork, you add something, the frequency of that tuning fork will decrease. When you file it means you decrease the mass or weight, the frequency increases. So these are the two things that you must remember, that loading a tuning fork decreases the frequency and filing the fork increases the frequency. Now having said that, you can use this and find out the unknown frequency of a tuning fork using this phenomena. So I'll give you a question and this is the question. A tuning fork having frequency of 300 Hz produces 5 beats per second with another tuning fork. If wax is added on the arm of the known tuning fork, now wax could be added on the tuning fork whose frequency is known. It can also be added to the unknown tuning fork. So depending on which tuning fork you have added wax, the answer would be different. If the wax is added on the arm of the known tuning fork, the number of beats decrease. Calculate the frequency of unknown tuning fork. This question has got very less to do with physics, even maths. This is more about a question of applying some common sense. So you can apply that common sense, try it on your own. I'll give you 2 minutes. If you're not able to do it, let me know. I'll do it for you. Yes, the answer is 295 hertz. How did you get it?
Sir, beat frequencies, difference between beats, no, sir. I think
Yes.
5 beats per second.
So this known is having 300 hertz frequency. So the unknown can be 295
And 305.
or it could be 305. So you have to find out which one is this. Now, how do you find out? Now, when you load the known one, so let us say its frequency will become from 300, it might become 301 because it has to increase or decrease.
Decrease, sir, it should be.
It should decrease. So that is what you got to remember in this question and nothing else. If you remember that, 299. Now the frequency must, the number of beats have decreased. If the answer would have been 305, the number of beats would have become 6.
6.
But no, the number of beats have decreased. It is only possible when the answer, when the unknown frequency is 295 hertz, and this is how you find it out. Depending on which of the tuning fork is loaded or filed, you should be able to find out the unknown frequency. Do we understand this?
Yes, sir.
One more. I'll give you one or two more so that you understand the basic phenomena. If there is a question on beats, it may be coming from this type. A tuning fork having frequency as 150, 158 hertz produce 3 beats per second with another. As we file the arm of the unknown, beats become 7. Then calculate the frequency of the unknown. I'll give you 2 minutes to give me the answer. How did you get 161?
Sir, the beat beat frequency has given. So as we file the unknown, it's means frequency increases, no, sir. So if it is less than 158, then beats will be decreased.
So let us, since this is given as 158 and it produces 3, so the answer could be either 155 or it could be 161. Now, if you file this, if you file this one, the number of the frequency will increase and from 3 to 7 it can become. If you file this, if you file this, then what would happen is this will increase and it can be, and it will become less, but it's a small problem. If you keep on filing this 155 can also become 163. Yes or no? Yes or no?
Yes, sir.
See, for if you file 161, it can become 165 by filing, yes or no?
Yes, sir.
But if you keep on filing 155 also, it can also become 165, yes or no?
Yes, sir.
That means the answer in this case can be either of the two. We don't know precisely how much we have filed, yes or no?
Yes, sir.
So the answer can be both of these. This question, such question should not come, but I'm just showing it to you so that you understand. In most of the cases, what they do is they load it, and the answer is pretty simple. Okay, I'll give you one more. Have you understood the answer in this case?
Understood, sir.
Now remember, for this reason, in most of the cases, whatever is done, whether it is filing or it is loading, it is done on the known frequency. On the known frequency. We can only do it on the known frequency because on the known frequency, we will know what will happen. If we do it on the unknown frequency, then it becomes a confusing thing. Do we understand? Here it was done on the unknown tuning fork, and that is why both the answers were possible. Do we get my point?
Yes, sir.
This is the next one, and I hope that you can give me an answer. I'll give you 2 minutes to do this. Yes, the answer is, I think, 96. How are you supposed to get this? This
Same
is
that
same.
four question.
This
Like
is 100.
first question.
So the answer is either 96 or 104. Now I have loaded this one. When some mass is added, so it is loaded. So this frequency will decrease. Frequency of beat also decreases. Therefore, the correct answer has to be 96. Do we understand this? Or it has gone above our head saying bye bye, sir, bye bye, sir, I'm going, sir, bye bye, sir.
Understood, sir.
Pakka, sir?
Yes, sir.
Okay. Here comes the next question, sir. Two strings X and Y. These questions are more likely to come. Two strings X and Y of a sitar produces a beat of frequency 4 Hz. When tension of Y is slightly increased, the beat frequency of is found to be 2 Hz. If the frequency of X is 300 Hz, find the original frequency of Y. I will give you 2 minutes to give me this answer. Yes, the answer is 296. How did you get it?
Sir, has we increased the tension?
Frequency is 1 by lambda into root over T by mu. Remember for strings?
Yes, sir.
So if you increase the tension slightly, the frequency will increase.
Yes, sir.
It is given that the unknown X is 300. X is 300, so Y can be either 302 or 296. Now Y tension has been increased, so its frequency will increase. If it was 302, it will become 303. Beat frequency will increase. Therefore, the answer has to be 296. Do we understand this? Yes or no? No or yes?
Yes, sir.
Pakka, everyone? Do we understand this? Yes or no? No or yes? Yes or no?
Yes, sir.
Let's see if you can do this one. And again, it requires Two topics mixed together. This is a favorite topic of JEE Advanced. So let's see if you can do this. A string 25 centimeter long is fixed at both ends, having a mass of 2.5 grams is under tension. A pipe closed from one end is 40 centimeter long. When the string is set vibrating in its first overtone and air in the pipe is in fundamental frequency, 8 beats are heard. It is observed that at decreasing the tension in the string, decreases the beat frequency. If the speed of sound is 320, find the tension in the string. And I'll give you 3 minutes to do it. Do it aram se. It encompasses everything that we have done. Standing waves in strings, standing waves in air columns and beats together. Take your time. Let me know once you are done. And let us move ahead. I hope you know how to do this. Can you tell me how are you doing this? No one knows
Sir,
it. So what we do is first let us find out the mu for the string. What is the mu for the string? Mass per unit length. So it is 2.5 into 10 raised to the power minus 3 divided by 25 into 10 raised to the power of minus 2. So how much is coming? It is coming 10 raised to the power of minus 2 kg per meter. Yes or no? Yes or no?
yes, sir.
Now the string is in its first overtone. Is first overtone is the second harmonic. Yes or no?
Yes, sir.
So frequency of the string will be second harmonic. What is the formula for second harmonic? How much will be its lambda?
1 by 4L into under root T by mu. Sorry. First overtone, no, sir.
String is fixed at both ends. Take a deep breath. Deep breath. Deep breath. Very deep breath. How does the first overtone of a string fixed at both ends look like? It looks like this, my dear friend.
Yes.
So lambda will be equal to
25.
L 25 centimeter 25 into 10 raised to the power minus 2. So I can write the frequency of the string as 1 by 1
25.
by 25 into 10 raised to the power minus 2 into root over t by 10 raised to the power of minus 2. Yes or no? No or yes?
Yes, sir.
Then I will repeat the same thing for the pipe. So what is the frequency of the pipe? It is in its fundamental
V by
closed
4L.
pipe, closed pipe in its fundamental. So what will be the its wavelength? 4 times L, yes or no?
V by 4L.
V by 4L, and so V is 320 divided by how much is 4L?
4 into 40 into 10 to the power of minus 2.
So 1.6. Yes or no? No or yes?
Yes, sir.
So now we hear how many beats? 8 beats, right? Are heard. 8 beats are heard. It is observed that decreasing the tension in the string. When you decrease the tension on the string, the frequency of the string will get low. Yes or no?
Yes, sir.
And the beat frequency also decreases. So which frequency will be more? String wala frequency is more or pipe wala frequency is more?
Spring, sir.
Not spring, string. String is more. So from that we understand that Fs minus Fp should be equal to A. Do we understand this? Yes or no? No or yes?
Yes, sir.
We just put this, get the answer and stay happy. So 1 by 0.25 root over t by 10 raised to the power minus 2 minus 320 by 1.6 is equal to 8. This is a very simple equation, and I think the value of t that is given to me is approximately 27 Newton. That is the answer that we are looking at. Do we understand how this was done?
Yes,
Yes
sir.
or no? No, yes. Huh?
Yes, sir.
Pakka na, sir.
Yes, sir.
Okay, have you noted this down?
1 minute.
Noted down?
Yes, sir.
Then this is the next question coming. It might require some calculation, but I'm not worried about the calculation. I am more worried about whether you have understood the concept or not. So give me the answer first. The wavelength of two sound waves are 49 and 50 centimeters respectively. If the room temperature is 30 degrees Celsius, then the number of beats produced by them is how much? Remember, the speed of the sound is given at 0 degrees Celsius and the room temperature is 30 degrees Celsius. So you must remember that. I'll give you a minute to give me the answer for this one.
No, sir.
Okay. So how are we supposed to do this? So the velocity of sound at 0 degrees is given. You have to first find the velocity of sound at 30 degrees Celsius. How will you find the velocity of sound at 30 degrees Celsius?
Sir, your voice is breaking, sir.
Velocity of sound at 30 degrees Celsius is, you have to convert it into Kelvin. Have you converted into Kelvin? And velocity of sound at 0 degree Kelvin is given. So we call it 0 degree Celsius is given. So we call it 273. Do we understand this?
Yes, sir.
So that will be root over speed of sound is directly proportional to the temperature. So it will be 303 divided by 273. Yes or no? You
Yes, sir.
understand this? Speed of sound is directly proportional to the temperature. Yes or no?
Yes, sir.
So speed of sound at 303 degree will be, again you will have to calculate it, 332 into root over 303 by 273. Right? Now,
Yes, sir.
you have to find out the beat frequency. So F1 minus F2 can be written as V by lambda 1 minus V by lambda 2. Yes or no?
Yes, sir.
So you can take V common. V is speed at 303. 1 by lambda 1 is 1 by 49 minus 1 by 50. And you just put the value of V from here, from this equation, and you will get your answer. Do we understand how this is done?
Yes, sir.
Okay, I'll give you a minute to note this down. Note it down fast. So Doppler's effect happens whenever there is a relative motion between the source and the observer. Now, now what happens when there are different cases that we will have to understand, different cases that we have to understand. The first case that we are going to do is case number 1. Source is moving. Source is moving. Source is moving and the observer is at rest. So this is, let us say, my source, and this is, let us say, the observer. Okay, now this observer, here also there are two cases possible. Case number A, source is moving towards the observer. So let us do this case. Oh, okay, let us first do the general case. Let us do the general case. What happens when source is moving, whether it is moving towards the observer? Vs is the speed of the of the source. C is the speed of sound, and Fs is the frequency that is emitted by the source. These are the three terms that we have to understand in terms of the source. Now, whenever the source is moving and the observer is stationary, the observer the observer the observers hear sound with same speed or velocity but different wavelength. Can you hear? Can you see me, everyone? Am I audible? Am I visible to everyone?
Yes, sir.
So here he will hear sound with the same speed he will see will be same, but he will receive sound of a different wavelength, and therefore the frequency
Different
changes.
frequency.
Speed is same, but the frequency change, but the wavelength changes. In here we can do case number A. Case number 1, source is moving towards the observer, and this is the same scenario that I've drawn. This is source S. Vs is the speed of the source. Do we understand this? O is the observer. Observer is stationary. C is the speed of sound, and Fs is the frequency emitted by the observer. This observer will receive sound with the same speed but different frequency f naught with a different wavelength lambda naught. Lambda s is the is the wavelength emitted by the source. Do we understand this? Do we understand this?
Yes, sir.
This is what you have to remember. If you can remember this, this is the most important aspect. Do not mix the two, because if you mix the two, then we are gone. So do not mix the two. Keep them separate. And here what you have to understand is two things. Lambda naught, the frequency, the wavelength received. Lambda naught, the wavelength received is C upon C minus Vs into lambda of the source. And therefore, the frequency received, the frequency received will be lambda naught V divided by lambda naught, and you put the value of lambda naught, you will get the answer as, everyone noting this down?
Yes, sir.
C upon C. Oh, I'm writing it reverse. I've written, I think, lambda in the reverse sense. That is why I'm getting confused. What is wrong? I've written lambda in the reverse sense. Lambda should have been C minus Vs. That is what has got me confused so much. Yes, now it is correct. And F naught becomes C upon C minus Vs into Fs. I always get confused between these two formulae. I don't know why. I could never remember them. And I always find difficulty in remembering them. Okay? Have you noted it down correctly?
Yes, sir.
Remember one more relation. C, the speed of sound will be equal to Vs into Fs. And here also C, oops, here also C will be equal to F naught into lambda naught. So if you multiply these two, which you can see from both the things, when you multiply them, you will get F naught into lambda naught is equal to Fs into lambda s. Are we getting this? Yes or no?
Sir, you have written C equals to Vs into Fs.
Oh, what is happening? Fs into lambda s. Okay. Do we understand this?
Yes, sir.
Now, similar is the case number B. Similar is the case number B when the source is moving away from the observer. Now, in this case, This is the source and it is moving like this. Do we understand this? This is the observer. Again, he is emitting sound with speed c, frequency lambda s, frequency fs, wavelength lambda s. He is getting sound c, f naught, lambda naught. Again, the same equation is valid. C is equal to fs into lambda s. Here, c is equal to f naught into lambda naught. Same formula will come. The only difference is, what is the difference?
Velocity will be plus C plus Vs.
I'm fed up with this. So lambda naught will be c plus, I'll give you 2 minutes after this, and I will into lambda s, and f naught will be c upon c plus vs into fs. Do we understand this, everyone?
Yes, sir.
I'll give you 2 minutes to note this down. Case
Observer.
number 2. Case number 2. Source stationary, observer in motion. That is case number 2. Source stationary, observer is moving. What happens in this case? What happens in this case? So, if I draw the diagram, this is the source. He is stationary. He is emitting sound with c, speed c, frequency fs, and lambda s. Here is the observer. Observer might be having some velocity. VO is the velocity of the observer. Now, what happens here is he receives sound with the same wavelength lambda s, but the speed changes. The speed becomes c dash, and therefore the frequent let me not write it as c dash, I will write it as c naught, where c naught is the speed with which he perceives sound. Do we understand this? So
Yes, sir.
observer receives sound of same wavelength but different speed. Now again here two cases are possible. What is case number A? First listen to me, then write. Observer moving towards source. I will write all the two cases and then you can copy them. Observer moving towards source. Have you written the upar wala one?
Yes, sir.
Now listen to me and then you will write. So this is the source S. It is stationary, it is not moving. C, Fs, lambda S. Observer moving with a velocity V naught. He receives the sound with C naught, F naught, and lambda is same as lambda s. So here again, we have to understand that this C naught, the speed that he receives the sound is different. So the value of C naught here is C plus V naught. Do we understand this? The speed of sound that he receives, the speed at which he receives sound is C plus V naught. So now I can write the relation here. If you remember this relation, C is equal to Fs into lambda s. And here you will have C naught is equal to C naught, which is equal to F naught into lambda s. But this C naught is C plus V naught. Do we understand this, what I'm writing here? Do we understand what I'm writing here?
Yes, sir.
So from this equation, I can find the value of F naught. F naught will be equal to C plus V naught divided by C into Fs. So he receives the sound with the same wavelength but different speed. Option number B. Can you write the other option? I'll give you 5 minutes. Write it down. Can you write the other option on your own? Try it. So what will be the next case? Observer moving.
Away from source.
Great. What will be the case there? Tell me.
Sir, C naught is equals to C minus V naught.
Okay. He
F
will
naught,
receive, first tell me, he will receive sound with what? Same thing what? Different what?
same wavelength and different frequency and speed.
Different frequency, no, different speed, therefore different frequency. Okay. Then what is the relation between the speed he receives and the actual speed of sound?
Sir,
Tell me what next? Tell me what is, whatever you want to say.
nothing, sir. That C is equals to Fs into lambda s and C naught equals to F naught into lambda s.
Okay, what will be the formula of frequency that you will get?
F naught equals to C minus V naught by C into Fs.
Okay. So we have understood this. Now we can go to the general case. And what is the general case? Case number 3, general case. Case number 3, general case. Now in general case, we can write the equation in the general case. How can we write the equation in the general case? Like this. Let us say this is your source and this is your observer. Source is S, observer is O, source is moving with a velocity Vs, observer is moving with a velocity V naught. As you can see, this is the direction of sound. Yes or no?
Yes, sir.
This direction of sound is taken as positive. The direction in which sound is moving is taken as positive because we are going to make a general formula which works everywhere. Do we understand this?
Yes, sir.
Okay. He is emitting sound. He is emitting sound with speed. The speed of sound is c. Frequency is fs. Wavelength is lambda s. He is receiving sound c naught, f naught, lambda naught. Do we understand this? Or this has gone above our head saying bye bye, bye bye, bye bye.
Understood, sir.
Huh?
Understood, sir.
Pakka no, sir?
Yes, sir.
Then what will be the formula? If I make a general formula, what will be the general formula? If I make the general formula, how does it look like? The first thing, the first formula is C naught. C naught will be C minus V naught. Do we understand how I got this formula? Yes or no? No, yes.
Yes, sir.
Pakka? Do we understand how this formula is working out? Okay. The second formula is for lambda naught and lambda s. Remember, I'm writing all the formulas in different ways. Lambda naught can be written as C minus V naught divided by F naught. Yes or no?
Yes, sir.
Do we understand this?
Yes, sir.
Pakka?
Yes, sir.
How can I write lambda s?
Sir, C by Fs, sir.
Hmm? C by Fs, sir. Yes or no, sir?
Yes, sir.
Okay. Now, I can write F naught in terms of Fs. How can I write F naught in terms of Fs? I have to combine both the formulae together. I hope you understand this. So I can write it as C minus V naught divided by C minus Vs multiplied by Fs. Yes or no? Yes or no?
Yes, sir.
So from here, I can also write C minus V naught divided by F naught is equal to C minus Vs divided by Fs, and this is nothing but equal to lambda naught. So these are the various ways in which I have written the same formulae, so that in any form if they come, you should be able to find out whatever is required in the most general form. Do we understand this?
Yes, sir.
Do we understand this, everyone? Can I have raise hands from everyone that we understand this? No one is going to ask you the wavelength. They are only going to ask you the frequency, but I have also given you the formula of wavelength. Do we understand this?
Yes, sir.
Now, sometimes, sometimes, sometimes They may not be traveling in the same straight line. Sometimes they may not be traveling in the same straight line. In that case, what will you do?
Resolve them.
Resolve them. So you can write if they are not in same straight line, VO की जगह, in place of VO, I must choose VO parallel. What do you mean by VO parallel?
Velocity of observer which is parallel to velocity of sound source.
Velocity source? No. Think again. Think again. Think again.
Velocity of sound, sir.
Velocity of sound. Yes, you can say velocity of sound. So for example, if your source is like this, ding, 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 it is going like this. Your observer is somewhere here and is going like ding, 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 here like this. Then what? What do? I resolve them into ding, 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 ding. Do we understand this?
Yes, sir.
Ah? What, sir? I will have to resolve this velocity along this direction and this velocity along this direction. Do we understand this? Along the line joining the two, which is the direction of in which the sound shall travel. Do we understand this, or this has gone above our head saying bye bye, bye bye, bye bye, bye bye? Huh? Everyone got this? Everyone got this?
Yes, sir.
If wind is blowing, then what happened? Your C, wherever your C is there, C must be replaced by what? C must be replaced by C plus or minus W cos theta. What is this W cos theta? If your wind is blowing, if your wind is blowing, let us say this is your source. The source is moving like this. Let me take a simple case just to make you understand. Your source is moving like this and your observer is here. Observer is here. Remember, this is the direction of sound and your wind is blowing in this direction. Wind is blowing in this direction and this angle is theta. So if the wind is blowing in the same direction, it will be plus. If the wind is blowing in the opposite direction, it will be minus. We have already seen that effect of medium speed on wind. Yes or no?
Yes, sir.
So we have to replace this in this case. Do we understand this?
Yes, sir.
So if I keep everything together, if I keep everyone has noted this down.
Yes, sir.
If I keep everything together and I will just write the formula of F naught, if I put everything together and if I write the formula of F naught will look like this: C plus W parallel minus V naught divided by C plus W parallel minus Vs times Fs. And here the direction of sound is taken as positive. Do we understand this? Here I must also write VO parallel and S parallel. Parallel means along the direction of the line joining the two bodies. Yes or no? No or yes?
Yes, sir.
Everyone has understood this? Now I will give you 2 minutes, 3 minutes. Take a deep breath. Deep breath. Very deep breath. Go through all these and then I will move on to question. Take a deep breath. Understand these formulae. Write them on your own once. And then I will move on to questions. You can also note down two more points here. And uh, the next point that you can note down, if they are moving in the same direction with the same velocity, if VO is equal to VS in the same direction, then F naught will be equal to Fs and there will be no Doppler effect. That means if it is like this, source moving with Vs, an observer also moving in the same direction with the same velocity, both are equal. Do you understand? Both are equal. There is no relative motion, so there is no Doppler effect. Yes or no?
Yes, sir.
Also, if the source and the listener move at right angles to each other, there will not be any Doppler effect. So that is the next point that you can write. If the source and the observer are at right angles to each other, there will not be any Doppler effect. What does that mean? If I have, let us say, if I have the source moving like this in a circle Vs and the observer is here or the vice versa, there will not be any Doppler effect. Do we understand this? So this has gone above our head saying bye bye. We understand this?
Yes, sir.
Okay. So in that case also there is no Doppler effect. So these are the cases of no Doppler effect. And there are again 2 or 3 points which you may note down together with this when there is no Doppler effect. If the velocity of the source and the listener is equal to or greater than the sound velocity, then there is no Doppler effect. It only gives us information about the frequency change, not about the intensity. Just note it down. The last point, you may note it down, you may not note it down. It is not that important. So Do we understand this? Yes or no? No or yes?
Yes, sir.
Okay. Have you noted it down? Shall we move ahead and solve some questions?
1 minute, sir.
Okay, let me know once you are done so that I can move ahead. One more thing you have to note down. No Doppler effect is observed. No Doppler effect is observed if only medium is moving. As you can see, if VO and VS are 0, if only wind is blowing, you will not see any Doppler effect. Do we understand this? Yes or no? No or yes? We understand this? Yes or no? No or yes?
Yes, sir.
Now can you move on to some questions? This is the first question that we are
Sir,
supposed
1 minute
to do.
previous on that last point.
A source of sound of frequency 90 vibration per second is approaching a stationary observer with a speed equal to 1/10 the speed of sound. What is the frequency heard by the observer? So this is the question and these are the previous points. Go through the previous points, solve this question and let me know the answer. I'll give you 2 minutes. 100 vibrations per second, that happens to be the right answer. How are we supposed to do this? I can straight away apply the formula. FO is equal to C minus V naught upon C minus Vs. There is no wind into Fs and the direction of sound is positive. Okay.
Yes, sir.
Observer is not moving, so this is 0. And the source is moving towards the observer, so the velocity is positive. So my final formula becomes F naught is equal to C upon C minus C by 10. Yes or no?
Yes, sir.
Into Fs. Fs is 90. You can solve it, get your answer, and stay happy. Do we understand this? Yes or no? No, yes.
Understood, sir.
Can you move on to the next question, sir?
Yes, sir.
This is the next question, sir. Do it fast, sir. The more the question you do, the more the question I can give you. Else I will have to stop at certain point in time. So we have an answer again. And the answer is pretty simple. Yes or no?
Yes, sir.
F naught is equal to C minus V naught upon C minus Vs multiplied by Fs. Your observer is stationary and the source is moving towards the thing. So Vs will be positive. It will become 330 upon 330 minus 30. Yes or no?
Yes, sir.
Everyone got the answer? Did we get the answer?
Yes, sir. 550.
Okay, can we move on to the next question? Do it fast so that I can do more questions. This is the next one. The source and a listener are moving towards each other with speed v by 10, where v is the speed of sound. If the frequency of the note emitted by the source is f, what is the frequency heard by the listener? I'll give you 1 minute. So how are we supposed to get the answer for this one? You just have to get used to the formula. And the formula is what? F naught is C minus V naught upon C minus Vs multiplied by Fs. Here both V naught and Vs are V by 10, but V naught is in the opposite direction and Vs is in the same direction. Yes or no? No, yes.
Yes, sir.
So F naught becomes C plus C by 10 divided by C minus C by 10 multiplied by F. So it will be 11 by 9 times F. We understand this? Yes or no?
Yes, sir.
Now, before going ahead, you can write two uh, we can just do one more thing so that we can do all the questions together. You can see Doppler effect in reflected sound. Okay. Now, what is going to happen here is if you have a case like this, case number 1, you have a source which is which is approaching a wall or a obstacle which is going to reflect the sound. Do we understand what I'm saying?
Yes, sir.
Now, if this is your source S and this is moving with a velocity Vs towards the hill or a wall, it is emitting sound with a frequency of Fs, and c is the speed of sound. After reflection, what is going to happen? This will actually also behave as a source of sound which is moving like this. Do we understand this?
Yes, sir.
So it is moving in the opposite direction with a speed with the opposite speed, and this person will be hearing a different frequency then. So if this person will be hearing the sound at a different frequency, he also becomes the observer and he's also the source which is emitting sound. Yes or no?
Yes, sir.
So he also becomes an observer. What is the frequency of the reflected sound that he will hear? The frequency of the reflected sound that he will hear, if I call it as F naught, this F naught will be equal to how much? It will be equal to C plus Vs divided by C minus Vs with the proper sign convention I am putting it multiplied by Fs. Do we understand this?
Yes, sir.
Everyone understands this? Yes or no? No, yes.
Yes, sir.
He is the observer, he is also the observer, and he is also the emitter of source. I hope you understand this. Yes or no?
Yes, sir.
Have you noted this down?
Yes, sir. 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 Yes, sir.
Have you noted this down? Can I give you a question on this? Yes or no? No, yes.
Yes, sir.
Okay. This is the question that I am going to give. A motor car blowing a horn of 124 vibrations per second moves with a velocity 72 km per hour. Remember, everything has to be converted into meter per second towards a tall wall. The frequency of the reflected sound heard by the driver would be, I'll give you 2 minutes to give me the answer. 140 vibrations per second is correct. What you have to apply is very simple. F of the observer to the driver itself will be C plus speed of the source, which is the observer also, plus C minus V8. I put the sign convention already in this. Do we understand this?
Yes, sir.
Into Fs. This Vs is 72 km per hour. You have to convert it into meter per second. How much is that?
20.
20. So it is 330 plus 20, 350 divided by 330 minus 20. So 330 by 310. Do we understand this?
Yes, sir.
Everyone got this answer? I'm girls, boys.
Yes, sir.
This is the next one. This is the next one. Question number I forgotten. I'll call it 1. The driver of a car traveling with speed of 30 meter per second towards a hill sounds a horn of frequency 600 hertz. If the speed of sound in air is 330 meter per second, what is the frequency of the reflected sound? Do it fast. 720 hertz is correct. You just have to put the formula. Shall I do it or you have understood this? Everyone has understood this? Yes or no?
Yes, sir.
Okay. Then we can do here one more case. Case number 2 of reflected sound. Now case number 2 of reflected sound would be like this. And again, everything depends on how the source and the observer are placed. Let us say this is an observer which is stationary and this is a source S that is moving with a speed Vs towards a wall. Do we understand this?
Yes, sir.
He is emitting a sound of frequency Fs. Now, this observer will be hearing two sounds, one coming like this, which I called one sound coming directly to him like this. I call him the direct sound. Yes or no?
Yes, sir.
And one would be reflected by the wall. And you can assume that the wall is a source of sound which emits a sound of frequency emitted by the wall. Frequency emitted by the wall is frequency of source into C upon C minus Vs. Wherever a wall comes, you can assume that the wall is emitting sound of this frequency. Do we understand this?
Yes, sir.
Because it is getting reflected and source is moving towards it, so you can assume it in this way. Now this will be the reflected sound that he will hear. Yes or no? No or yes?
Yes, sir.
So he will hear two frequency. One, the direct frequency FD will be just because of source is moving away. So if I put the sign conventions correctly, it will be C upon C plus Vs into F naught. Yes or no?
Yes, sir.
If I look at the reflected sound, the frequency of the reflected sound will be, it is just coming like this. Yes or no? So this will be
Yes, sir.
C upon C minus Vs into F naught. Do we understand this? Oh, sorry, not F naught, Fs is the frequency of source. Do we understand this?
Yes, sir.
So he will actually hear beats. You can find out the frequency of that beats. Frequency of the beats will be C into Fs taken common, 1 by C minus Vs minus 1 by C plus Vs. Do we understand what I'm writing here?
Yes, sir.
So this is the case, the most difficult case which can come. I don't think it can come in a JEE main. It can only come in a JEE advanced. I can make this case more different by placing this observer. This observer can also start to move. He can start to move like this, or he can start to move like this. Then again, you have to see how you are going to do this question. For the direct sound, they are moving, one is moving here and the other one is moving here. For the reflected sound, this observer is moving away. Do we understand this?
Yes, sir.
Then again, I can make a different case where I can place the observer also here. So he hears one sound like this and the other sound coming from the back. So depending on where the observer is placed, you can make large number of cases. There is no point for us to do all those. If we understand this, for the direct source, the frequency is Fs. For the reflected one, the frequency is Fs into C upon C minus Vs. Do you understand this?
Yes, sir.
Yes or no?
Yes, sir.
So having said that, you should be able to find out any question based on this. I have not seen any question up till now. I saw a question way back. Again, it will take too much of time, so let's not get into that. This is the type of question that are coming in exam these days. A man is watching two trains, one leaving, another coming. So one is leaving him, other is coming with a equal speed of 4 meter per second. If they sound their whistles, each of frequency 240 hertz, the number of beats that he is going to hear. I'll give you 2 minutes to solve this. Well, I think the only place we can get stuck is the calculation part. One of the train is approaching, we'll hear more frequency. One of the train is receding, we will hear less frequency. Yes or no?
Yes, sir.
So I can just write the first one, the frequency of the approaching train will be more. Yes, so it will be C, which is 320 divided by 320 minus 4. Yes or no?
Yes, sir.
Multiplied by 240, that will be the frequency of the approaching train. Frequency of the receding train, which is going away from me, will be equal to 320 upon 320 plus 4. Yes or no?
Yes, sir.
Multiplied by 240. What is the frequency of beats? Frequency of beats will be frequency of approaching minus frequency of receding. Yes or no?
Yes, sir.
So basically what you have to do, frequency of beats will be, I think, 320 into 240 divided by 1 by 316 minus 1 by 324. You can calculate this. These type of questions don't come. They will give you a question where the calculations would be much easier. I just wanted you to do this. That is why I have done this. Do we understand this?
Yes, sir.
Everyone got this? Yes or no? No, yes.
Yes, sir.
Now, these are the questions that have come in your JEE main. So let's attempt a few for you to have understanding of what type of question you can expect. Two sources of sound S1 and S2 just like you were trained. Produce sound of the same frequency 660 just like you were trained. A listener is moving from source S1 to S2. So instead of train moving, the observer is moving with constant speed u. He hears 10 beats per second. What is the speed of sound? If the speed of sound is given, what is u equal to? I will give you 2 minutes to solve this. Everyone understands the question?
Yes, sir.
2.5 meter per second is the correct answer. What you got to do is just draw a simple diagram. Let me call this as S1. Let me call this as S2. Both the sources are stationary. The observer is moving with a velocity v naught like this. Yes or no? So what is the frequency heard from the source F1? The frequency heard from the source F1 will be 330 minus u divided by 330 multiplied by 660. Yes or no, my dear friends? So you can see the calculations are so simple. Yes or no? Yes or no?
Yes, sir.
F2 will be 330 plus u divided by 330 into 660. Yes or no?
Yes, sir.
And this F1 minus F2 is given as how much?
10, sir.
10. From there, you can find out the value of u. This is simply 2. This is simply 2. So you can find out the value of u, and the correct answer that is coming is 2.5 meter per second. Do we understand this? Yes or no? No, yes.
Yes, sir.
Now, before going on to solving more problems, we can do two more cases here. I have not seen these cases come, but let us just write this so that we can end up with the problems. The next case is source is revolving in a circle and the observer is on one side of the circle. That means observer is not on the center. I've already told you if the observer is on the center of the circle, nothing happens. Here the source is moving. The source is moving. I hope you understand this. Source is moving like this, Vs. And this Vs is nothing but equal to omega r. Do we understand this?
Yes, sir.
And what condition is given that your observer is here? Do we understand this? Observer is stationary on one side. He can be on this side, he can be on the other side. Do we understand this?
Yes, sir.
You can find out at different points the frequency would be different. If I call when the observer is at point A and B, when the observer is at point A and B, frequency received from point A and frequency received from point B will be equal to Fs only because there is no Doppler effect. Why there is no Doppler effect? When he is at points A and B, there is no Doppler effect. Why there is no Doppler effect?
Perpendicular, that is.
There is no Doppler effect because it is perpendicular. Do we understand this? Yes or no?
Yes, sir.
Now, at this point, and you can do it for any point, but I don't think they will ask. At this point C and at this point D, at one point he will hear maximum frequency, at one point he will hear minimum frequency. At which point he will hear maximum frequency? Huh? At point C, he will hear maximum frequency because the observer, the source will be coming directly towards him. And the formula will be C upon C minus R omega into Fs. Do we understand this or this has gone above our head saying bye bye? Bye bye, bye bye, bye bye. Bye bye, bye bye, bye bye. Do we understand this?
Understood, sir.
At which point he will earn minimum? At point D he will earn minimum. Do we understand this?
Yes.
F at point D will be F minimum. Yes or no? No or yes. And what will be the value of this minimum? C
Yes, sir.
upon C plus R omega times Fs. Do we understand this, or this has gone above our head saying bye bye? Bye bye. Bye bye. Now these are very typical questions that may come. The probability of these questions coming in JEE main is very slim. Probably in JEE advanced. I'll give you a minute to note it down because one more case is remaining, the reverse case. What is the reverse case? The listener will be moving in circles. Now remember, if this point O is on the other side, the condition reverses. C becomes minimum and D becomes maximum. Do we understand this?
Yes, sir.
Huh? Note it down first. Then we come to this case where the observer is moving in circle and source is on one side. At point A and B, what will be the frequency heard? At point A and B, huh?
0, sir.
0, sir? No, sir. Frequency of the source, sir. This is not 0, sir. The sound does not disappear that I don't hear any sound. There is no Doppler effect. Do we understand this?
Yes, sir.
Then at one point it is max and one point it is min. Which point it is max? Which point it is min? FC, it will be maximum frequency. Yes or no? No, yes. Hmm?
Yes,
And
sir.
the value will be how much?
C plus omega R by C into F naught. Fs. Fs, sir.
At this point it will be min because it is moving away with the maximum velocity. FD is F min. C minus R omega divided by C multiplied by Fs. I shall give you 2 minutes to note this down and then we shall move ahead. This is the question from JEE 2019 main. Same question, even the same values I had done in the class last year. Remember, questions are same. Same questions are going to come. Remember, every question that you are doing right now, even the same question, even with the same values can come in your exam. Anyways, this is the question. What is the answer? I'll give you a minute to do it. Do it fast. So, what is the frequency when he is moving away? So, how are you supposed to do this? The first frequency is given as 1000 hertz. Now, this 1000 hertz is when the source is coming towards him. So, this should be equal to 350 upon 350 minus the velocity of the source, which is given. How much it is given? 50. So 300 minus 300, 350 upon 350 minus 50 into F naught. Keep it as into Fs. Keep it at Fs. You don't have to calculate it here. The next frequency, let me call this as F. Now this F will be equal to how much? 350 upon 350 plus 50 multiplied by Fs. Just divide the two and you will get the answer. How long should you take to solve a question like this, beta? How long do you need? You've taken time till eternity to solve this. What is such a difficult question? Just because you saw that this question was from JEU, everyone is starting to look on the other side. Was it such a difficult question? Huh? F divided by 1000 will be equal to what? 300 divided by 400. 750 is the answer. See, I am an old person. My brain does not work. I don't know how to find out ratios. I always take ulta ratios. Still, I can do it. You can't do it. Shame. Do we understand this? Yes or no?
Yes, sir.
What, sir? I am very sad, sir. These are simple questions, sir. Again, I'll give you one more chance, sir. To redeem yourself, sir. A train is moving on a straight track with a speed of 20 meters per second. It is blowing whistle at the frequency of 1000 hertz. The percentage change in frequency heard by the person standing near the track as the train goes past him. What is the percentage change in frequency? Can I expect an answer from you? Yes or no?
Yes, sir.
Thank God, sir. 12% is the correct answer. How are you supposed to do this? Let me call the first frequency as F1. Remember, you don't have to calculate anything. You only calculate at the last. You don't have to even write this first frequency because it is going to get cancelled. So I will just write it at Fs and not as 1000. So this will be Fs into speed of sound. Let me call it as C because it is also going to, if you don't want to write it as C, you can write it as 320. Fs into 320 divided by 300. Yes or no?
Yes, sir.
The second frequency F2 is Fs into 320 divided by 340. Yes or no?
Yes, sir.
So the percentage change is F1 minus F2 divided by F1 multiplied by 100. Yes or no?
Yes, sir.
So this Fs and 320 will get cancelled. Yes or no? Fs and 320 will get cancelled from everywhere. Yes or no?
Yes, sir.
So what is remaining in the numerator? You will have 1 by 300 minus 1 by 340, and in the denominator you will have 1 by 300. That's it. So in the numerator you will have 40, and in the denominator you will have 340. Is 40 by 340 into 100, isn't it?
Yes, sir.
That is the answer. You don't have to calculate anything. At the end of the day, your answer is simply going to come as 40 by 340 multiplied by 100. Do we understand this, or this has gone above our head saying bye bye, sir, bye bye, sir, I'm going, sir, bye bye, sir, bye bye, sir? Huh? Do we understand this?
Yes, sir.
I'll give you one last question as an homework, and you can see this question has come previously in the exam, and I think I have already given you the formula for this question. A police car with a silent frequency of 8 kilohertz is moving with a uniform velocity 36 kilometer per hour towards a tall building which reflects the sound wave. So this is Doppler effect in reflected sound. Yes or no? You can find out the frequency heard by the driver. Yes or no? And do not write the question. Listen to what I'm saying. You have already done this question 2 times. This is the third time this question is coming.
Yes, sir.
It is nothing but the speed of the sound, reflected sound. You know the formula for that? Yes or no?
Yes, sir.
Well, that's it from my end. We are done with your. You can try this question at home. You just have to put the formula V naught plus Vs upon V naught minus Vs into Fs, and you will get the answer for this one. With this, we have done a major part of the 11th standard course. Still, we are not done with the 11th standard course. So, in the next class, we'll start with your thermodynamics, and I will try to wind it up in a week or so. That is my aim, so that from the 8th or 9th of January, we can start with your last major thing that is remaining, which is electromagnetism. And once that is over, well, almost your 2/3 of the course or 3/4 of the course will be completed. So we'll start with thermodynamics in the next class. Take care. God bless all of you. Bye bye, everyone.